Welcome back to a new video. Today we are learning about enum classes in Kotlin. So here I have a data class that has two entries, name type string, employment status of type string. And our employment status is going to be one of these possible values right here, student, employed, or unemployed. So here I'm just going to make three objects of this class. I will just paste them here. John is student, Mike is employed, Pete is unemployed. Here must be unemployed. Cool. Now say we want to iterate through these three objects and print I am an something. So like for example, John is a student, Mike is an employed. So for that, we're going to have a for loop, and we're going to say for every person in the list of P1, P2, P3, we want to check their employment status. So when, we're going to use a when, and we're going to say when person dot employment status, and here we're going to write our possible conditions. So first it's going to be student. If he was a student, we will print something. So person dot name is a student. Similarly for all the other values, so we're going to have a employed string, and here you're going to say is employed, e small e, and here just going to have an else statement, because if these conditions aren't satisfied, then we're going to go to the else block, and here it's just going to be unemployed, and we are done. Let's just run the program and see the result. So John is a student, Mike is employed, Pete is unemployed. So say for instance we wrote student incorrectly. We know we are humans, we make mistakes. Maybe we wrote it with a small s rather than capital S. So whenever we go within the conditions, we won't match the student condition right here, because small student that starts small s is completely different than a capital S. So let's just run and verify the output. And as you can see, we get John is unemployed, because John is not a student with a capital. So we're going to go to the else block, and we're going to print John is unemployed. And here comes the enum class. So whenever you have a set of possible values or a set of constants that you know they are not going to change, it's better to have them within an enum class. So rather than having something that resembles your status, for instance, like a primitive type or a string type, you would rather have an enum class. So here, let's just make our enum class. So I'm going to call enum class employment status. And here within the enum class, we add our constants. So the way to add them, or the convention, naming convention to write them, is with capital letters, and to separate them with a comma. So first I'm going to start with a student, comma, employed, comma, unemployed. Now within the class, we're going to change this from string to be of type employment status. And here we're going to have a lot of errors, so we're going to change this employment status to be of type employment status dot student, and for this one as well, so employment status dot employed. Lastly, for our Pete, employment status unemployed. And to match the conditions, what we do is just we're going to add employment status dot student, and here for employment dot employed. Now for the program, we're going to get the same result as the first time. So John is going to be a student, Mike is employed, and Pete is unemployed. So as you can see, it's just more convenient, and you know that you will not make a mistake, as if you did with a small s here, for instance, the compiler will give you a compile time error, and you won't face any logic errors within your conditions. So this is a more convenient way to do that. Now let's just talk more about the enum classes. So let's first talk about the entries or the constants of an enum class. Now the constants of an enum class are considered to be of the same type as the class. That's why we were able to pass them here as an employment status in the person constructor. Also, the constants can have their own closures, so we can open a body for them, and within the body we could add our own functions or variables, for example. So here I'm just going to make a function that prints the status within every constant or within every entry. So I'm going to call print my status, and here it just prints students or student. Let's make it a len. Copy this, put it here and here, and this is employed, and lastly unemployed. Cool. And whenever we make an instance of employment status, we could call the function. But let's just delete all of this, and here I'm going to make val p is equal to enum or employment status. And we cannot make an instance directly of an enum class, so we have to call one of its entries. So I'm going to call student here, and now I have access to the student, and the p here is of type enum status. Now whenever I call p dot print my info or print my status, we won't be able to access this. So to make it accessible from outside, we will have an abstract function within the enum class, as their entries or the entries within an enum class directly extend their parent, which is the employment status. So any abstract function or abstract property that you'd have within an enum class, you should also override it to the children of the enum class, which are these entries right here. So I'm going to make an abstract one called fun print my status. Now we cannot add this function directly. We have to terminate the adding of the entries or the constants, as the enum class expects that you're going to add more entries. So to tell it that you have had enough, you're just going to add terminating semicolon. Great. And now you notice another error, that you have to add the override modifier for this function because it has the same name as the abstract function. So I'm going to do that for all of our classes or of our entries. And now notice here we could access the function, and we could also run the program. So we expect to get a student here. Cool. We know that we cannot create an instance of an enum class directly, though they can have constructors. And those constructors are automatically inherited to their constants or to their entries. So our employment status here, you're going to have a primary constructor that have the current balance. So current balance of type int. And you can notice the big error here because we have to add the constructor for each and every entry. So for the student, for example, I'm going to pass 0, and the employed maybe 2000, the unemployed only 500. And you could also access this attribute from outside of the class, but always make sure to tag it with val or var keyword to make it accessible from the outside. Cool. But what if you want to add more information? Maybe not in the primary constructor. You could have a secondary constructor. And always make sure to add anything that you want within an enum class after you have provided your entries. So make sure you have your entries first, then you add whatever you want later here. So here I'm going to have my secondary constructor. So my secondary constructor maybe going to record the grade of the student of type int. And you also have to add the current balance, because the current balance is a primary constructor, and we're later going to pass it to the primary constructor. Maybe you should revise or watch again my inheritance video. And here I'm going to pass this, and here we have to add the current balance from the primary constructor. So primary current balance here. We're going to make another constructor to have, for example, a boolean is currently looking for a job, is currently looking for a job. It's going to be a boolean. Here, just going to make it a boolean. Cool. And if you just notice in any of these constructors, you could just press Ctrl B. You're going to have an overload constructor. So you're going to choose which one to use. I'm going to use the first one for the student. So the student's going to be in 10th grade, and he has 0 balance. You could also use the named arguments. So I'm going to say current balance is equal to 0, grade is equal to 10th grade or 10th grade. And for the employer or the employed, I'm going to only pass the current balance, so I'm fine with the primary constructor. the unemployed, I'm going to use the secondary constructor, which is this one right here. So is currently looking for a job is true, and the current balance is the same as 500. Now, you saw, or we have seen that you can access the current balance when you annotate it with val. So these two entries here are not accessible from the outside because they are not annotated with val. And if you try to annotate them with val or var, you'd have an error because having val or var within a secondary constructor is not allowed. So how we can make this accessible from the outside? For example, grade is not here, as well as is currently looking for a job. So we have to open the primary constructor body just like we did before in the inheritance video, and we make more attributes here to resemble these two attributes. So I'm going to make a var grade, and this grade is going to be of type int, and maybe it's going to be nullable. Another one is currently looking for a job. You can name it whatever you want. It doesn't have to be the same name. I'm just having the same name because I'm not creative with names. And here I'm just going to have a boolean of type null. Cool. So whenever we use any of these constructors, we want to assign these guys variables to be within to have the same variables as the past values from our constructors. So when the grade, so I'm gonna access the grade with this. So this dot grade is referring to the grade here is equal to the grade, and this grade is referring to the grade right here. Similarly, here in the second constructor is currently a job. We have to add this first, so we're referring to this one is equal to is currently looking for a job. Now we can access them from outside because we will access these values, not these values here. And these values are already assigned to the values we pass within the constructors and the enums or the enums constants. Cool. So we here can say is currently looking for a job. And also we can say P is great. And if you want to iterate through every entry or every constant within your enum class, you could do this with the values function, which is normally found in any enum class. So I'm going to say for every const in employment status dot values. So you can see that the values returns array of employment status. Here I'm going to say print ln the const. And if we run the program, we are going to get the const name or the constant name. So I'm going to get student, employed, and unemployed. And if you'd like to get the position, so they are positioned starting from 0 to the end number. So 0 for student, 1 employed, 2 unemployed, and so on. You could also try to do that with the name and ordinal. So the ordinal returns the position, and the name returns the name of the class itself or the name of the entry. So I'm gonna just say do this here. So at position const dot ordinal, we have this name right here. Let's run the program. At the position of 0, we have student. Position of 1, we have employed. 2 for the unemployed. Lastly, for enum classes, they can inherit from interfaces, but not classes. So for instance, we're going to have an interface here called employment change. Employment change. And it's going to have only one function, which is one change. So what we're going to do here, just going to make our employment status enum class, inherit from or implement our employment change interface. And now we're going to have an error because we have to override the function here. So after the constants, we press Ctrl O and we override change function. Now, all you got to do is just override the function within the enum class. And whatever functionality you give this function is going to be implemented for all the entries here. But if you want to have custom functionality for each and every entry, you have to implement the function within the entry here. So here you can see a change, and here I'm just going to add println I was a student, student, now I am an employee, for instance, employed. Similarly for all the entries, so I was an employed, and I wasn't employed, and employed, now I am unemployed. And for the unemployed entry, we just have I was unemployed, now I'm an employee. And whenever you just make an instance of the entry, you could run the function by saying, what was the function name? Yeah, change. And now we're gonna run the program, and we're gonna get the result within the student on here. I was a student, now I'm an employed. And for instance, if we have if we just can implement the function within the parent body, for example, I am just a function, I'm just a fun, we're going to run the program just to verify that we get this output, not the parent output. And if we didn't override, we will get the parent output. Cool. So that was it for today's video. We learned about enum classes and how to set them up instead of having constants, primitive, or string types. Thank you for watching, and I hope I see you in the next video.